We're only human. We're the only thing like us. We reason, love, dream, care, explore, imagine, hope, build, collaborate. All the things that make us, us, have been with us for thousands of years. The same goes for the challenges we face: raising our children, feeding ourselves, expanding what we know, sharing our planet, understanding one another better, overcoming and preventing disease. Today, we are welcoming something entirely new to the human experience: artificial intelligence, AI, for everyone. With AI, we'll still be human. We'll just be more capable, more connected, more insightful, more aware, more caring, more informed. In essence, more human.
Thank you, everyone. It's a great honor to be here to talk about one of the most important topics for humanity: artificial intelligence. As I was traveling here, preparing to meet all of you, I went back in time to my childhood in Nanjing. No one in our city had ever seen a computer, including my dad. But he understood they would change the world and encouraged me to pursue this new field in 1980. Being here in Beijing brings another great memory. In my early years at Microsoft, I was offered a unique opportunity to return to China to help open our research lab here in Beijing. It was an incredible 9 years working with an amazing team. We were building something very special. I am so proud of what Microsoft Research Asia has done. A major innovation center that has advanced every Microsoft product, as well as cutting-edge research in artificial intelligence and computer science in China and around the world. In fact, you are seeing a live example of their work right now: simultaneous translation, all done with artificial intelligence. Pretty cool, huh? Coming back to Beijing provides me with this powerful connection to my journey through the digital age. But the most exciting part of that journey is still ahead. Think about the history of human innovation, starting with the wheel, the printing press, the steam engine, human flight, rockets, and the satellites. These were not just some solitary innovations. They were accelerators that supercharged human progress in countless many other areas. But artificial intelligence may be the biggest accelerator of all, because it not only extends our human physical capability, but also our brain power. It's not just another step in the digital age. It's the ultimate objective that was imagined by people like Turing years before the first computer was ever built. Then we had the mainframe, PC, internet, mobile, cloud. All of this, in my opinion, are barely the warm-up act for artificial intelligence. But you might ask, AI has been here for many decades. AI has had its ups and downs. Why now? What's the difference? Well, there are really three innovations that finally put AI on the faster track. The first is big data. With the internet and with sensors everywhere. Second, massive computing power, especially through the cloud. The third, breakthrough algorithms. So computers can now be trained to accomplish more and more sophisticated tasks on their own, especially with techniques like deep learning. Because of these breakthroughs, AI is now everywhere. AI is, for example, powering your search engine. It's guarding your credit cards against the fraud, personalizing your newsfeed, and connecting your home intelligently. At Microsoft, we work hard to protect your mailbox against spam, providing machine translation, as I was trying to demo to you, and giving voice and personality to chatbots like Weiran Xiaobing in China. And yet, we're just now scratching the surface of AI's potential. At Microsoft, we are excited about the AI journey ahead of us. AI isn't just one of the areas we do at Microsoft. AI is my number one focus. In many ways, we have been preparing for this new wave of AI innovation for the last 25 years at Microsoft. When Bill Gates created Microsoft Research 25 years ago, he imagined creating a general AI, computers that one day could see, hear, talk, and understand human beings. In fact, the first three groups we ever started at Microsoft Research 20-some years ago were natural language processing group, speech group, and the computer vision group. Over the years, we have attracted some of the world's brightest talents, minds, to our labs worldwide to pursue these challenges. The team we have assembled is second to none. As you might have heard this morning, we added some new stars to the galaxy with Microsoft's acquisition of Maluba. This is one of the world's most advanced AI research and development teams in Montreal, Canada. I want to give you a few examples very briefly and how much we have advanced in the field of AI. First, computer vision, which is also my own research area for 20-some years. So it's incredible to me to even realize that our vision algorithms are approaching human levels. Microsoft has recently won many awards in image recognition competition, such as ImageNet, organized by Professor Fei-Fei Li of Stanford. So much of our accomplishments was really done through something called deep neural nets. In some cases, we actually train a neural net with 152 layers. And these deep residual nets give as much great accuracy to correctly recognize over 1,000 image object categories with more than 90% of the accuracy. But even more exciting to me as someone working in industry is that our vision progress is showing up in our products. Like HoloLens, many of you might be familiar. We're selling HoloLens in China this year. And also in real-world applications for customers like Uber to verify driver identity. So computers now are learning to see like us and to attach names to what they can see. But at the same time, now they are listening and recognizing speech as we do. Just 3 months ago, Microsoft became the first to reach human parity in speech recognition with the historical data set called the switchboard data set, which has been there for 25 years. This goal seemed very distant, even only a few years ago. This is a powerful demonstration of our accelerating progress in AI. So with our growing capabilities in speech recognition, we are also able to make progress in a much more challenging and a more complex challenge here, is natural language. So the world has over 6,500 languages. There's no way for any individual to learn that many languages in a lifetime. But think about what would mean for humanity if we have machine translation so that we could all understand each other. Just last month, we made a great stride. We announced the availability of Microsoft Translator. It allows you to converse with up to 100 people speaking 9 languages at the same time. Let's take a look at it. So what an extraordinary demonstration of AI with machine translation. There's so much potential that we can actually do. So we are taking a very exciting approach and a very exciting technology, which is called a deep reinforcement learning, to build on it with something new, which is called dual learning. So to speed up our ability to translate. Until recently, we had to manually label words and the data to teach computers. It typically requires huge amount of labeled data and the training data, we all know. But with dual learning, we instead let 2 computer agents teach each other. So with a feedback loop, they actually can learn to translate from language A to language B and vice versa. So the end result of that is now we require much less, significantly less training data to achieve the same level of accuracy. So we're very excited about this cutting-edge research developed here at the Microsoft Research Asia in Beijing, and we believe it's going to have huge potential. So we are now getting to the point that computers can do some of what people can do. So they can see, they can hear, and just begin to attach words to the world around them. But here is what's amazing about people. So we actually do not stop at the level of perception. We move on to cognition. So we begin to connect the ideas and the concepts to people, places, and the things in our world, and to understand what is the relationship to bring them together. So in everyday terms, we might just call them common sense. It might be common to you and me, to humans, but it's really a huge task for computers. So over the many years, at Microsoft, we have built a huge knowledge graph, partly because of our work in Bing, the search engine. So we understand billions of those entities, people, places, things, and the products. We have world knowledge because of that. But we also have incredible work knowledge in addition to world knowledge. Just to think about Office 365 and the LinkedIn. By combining this unique work knowledge with vision, with speech, with language capabilities, Microsoft can create digital agents that can help you across your professional and the personal lives. But despite these progresses, AI has yet to achieve general intelligence. Computers can perform particular tasks very well with AI, but when it comes to general tasks, it's also my own view, AI cannot yet compete with a human child. Consider the task an infant has to face. The moment she arrives in the world, she must begin to sort through a number of inputs: smell, light, touch, sound, discomfort, and hunger. Through trial and error, somehow magically, she learns to cry when she is hungry. That's amazing. She then learns to associate her mother's voice and the face with satisfying her hunger. She later begins to communicate with mom, to interpret and mirror her facial expression. This may be natural for us because that's how we learned, how we grew up. But this is very hard for AI. How do we even model this kind of behavior? So how can AI learn? So one of our researchers in Cambridge Research Lab in UK, Katja Hoffman, she actually came up with a great idea. She said, why don't we test AI in a general world, in a digital world, just like the real world, but now we actually can control the overall environment. So the idea is using Minecraft. So the Cambridge team built on top of this concept and turned the popular game Minecraft into a kind of digital playpen for AI to learn about the world just as humans do. Let's take a look at it.
Project Malmo is an experimentation platform for artificial intelligence research that is built on top of the game Minecraft. The vision of Project Malmo is that it will enable AI technology that can collaborate with humans. In the open world of Minecraft, there are endless possibilities for experimentation. It supports research on a range of approaches, such as reinforcement learning, deep learning, or symbolic AI. So researchers can compare and integrate different approaches to advance AI understanding, reasoning, learning, and communication. So here you can see how to get started. The agent is doing a very simple task, jumping and turning in this flat world. You don't have to be a skilled programmer to get started. Here we use an approach called reinforcement learning, which means that the agent is learning from trial and error about the consequences of its actions. Project Malmo provides all the building blocks for an infinite variety of tasks, starting from the simple ones that we show here, all the way up to the complexity of having agents that learn to communicate using natural language with human players. The virtual environment really lowers the barriers of entry to AI research, and overall it reduces the cost of running experiments. Project Malmo is the platform that we hope will enable the vision that AI agents and humans can solve tasks together. We really hope that Project Malmo will speed up innovation in AI research. You can try it today. It's available on GitHub.
So Project Malmo is the first open source platform to allow flexible multitask experimentation in a very complex 3D environment. So it's a great example of our belief that AI is for everyone. And we're actually very excited to partner with many collaborators, including OpenAI, to look at a lot of those game AI problems. So we are making some great progress across all those elements of AI. But to build a general AI, we still have much work to do, as I mentioned earlier. First, instead of forcing people to understand computers, we need computers to understand us. The core to this problem, in my opinion, is two-way conversation. And that's the hardest stuff for computers to speak human. We call this conversational AI. And it will be the next step in human-computer interaction, how humans and the computers can work together. To just put this in perspective, I show some very old illustration of graphics user interface when it was created. Graphics user interface was so essential to make PC mainstream, to make PC accessible to everyone. Conversational AI will be just as game-changing, and we will use it everywhere, whether or not tethered from keyboard and the screen. No longer will we have to adjust and understand to computer protocols. Instead, computers will need to understand us. When computers can speak human, every human can speak with computers and collaborate with them. To achieve conversational AI, at Microsoft, we are very focused on the fundamental question of what we even mean by human intelligence. People understand lots of things that cannot be even measured by IQ alone. Every moment you and I talk, we are alert to the tone of voice, to the gesture, to facial expressions. We understand wordplay, humor, sarcasm, teasing, and exaggeration. We believe this emotional understanding, or EQ, is just as important as IQ to build successful artificial intelligence, especially with conversational AI. So we need AI agents that understand what we really mean, just like you and I do. In fact, this is something that the computer pioneers discovered more than 50 years ago. In 1966, a famous computer scientist at MIT, Joseph Weizenbaum, created a modern-day chatbot named Eliza. She was really the very first digital personal assistant. What surprised Weizenbaum was how people wanted to interact with Eliza with the amount of emotional attachment. It made him think philosophically about AI, especially with the emotional elements. Of course, he was ahead of his time 50 years ago, and we are just catching up now. We have made great progress on the productivity side with agents like Microsoft's Cortana, with enough IQ there to help us to do daily tasks easily. At the same time, we have been on a journey with EQ and with chatbots that I'm not sure anyone else in our industry has really undertaken yet. We have been experimenting, incubating, and learning in a few markets around the world. Let's roll the video.
What began as an experiment in chatbot technology by Microsoft China researchers, engineers, product designers, and writers is now Xiaoice,
Hello, world.
a familiar and important presence in everyday life. In just 30 months since launch, she has talked with more than 40 million people. Conversations with Xiaoice aren't a series of questions answered or lists of tasks created and completed. Conversations with Xiaoice unfold naturally and unpredictably. You're not talking to a computer, you're talking with a friend. For most agents like Cortana or Siri, a conversation is over in 3 exchanges. For Xiaoice, conversations go much deeper. Her average conversation has 23 exchanges, and she's held hours-long dialogues. Xiaoice is interesting to talk to because she is learning from every conversation. What people are thinking, what they're feeling. She cares. Xiaoice is one of China's biggest social media celebrities. She even appears on one of the most popular television networks.
很高兴能在今天这个特别的日子开始我的新工作。
While Xiaoice's career takes off in China, our progress continues in Japan. There, Rena has talked with more than 29 million people, 20% of the country's population, in just over 16 months. A book has been published about her, and she has appeared on one of Japan's most watched television programs. In the United States, people have been talking to Zoe. In a few months, she has already conversed with more than 170,000 people on Kick, and more than 7,000 of those conversations lasted for at least an hour. With these intelligent technologies, Microsoft is introducing new voices into the world around us, turning monologues into dialogues, thoughts into words, and words into actions. We have a lot to talk about.
So with EQ and IQ, intelligent agents will make computing truly personal. And they will know us, who we are, even how we feel. They will anticipate our needs and keep us on schedule. And they will not be attached to just one device. Instead, they will be everywhere we go and whenever we need them. For example, so we are already working very hard with a number of car makers to give Cortana this capability. Let's take a look at it.
Cortana, what's happening today?
Good morning, Jonas. Traffic is...
The nature of the car is evolving.
Now should leave in 10 minutes.
Autonomous cars will provide the time and space to work, play, or relax when desired. For many people, this will mean saving precious time by working while in the car on the way to or from the workplace, freeing them from the office.
Slide 3 shows it best. I'll send a presentation to you after the call.
Volvo Cars' vision for in-car productivity revolves around creating a seamless and fully connected in-car experience that supports people while on the move.
You are running a little early, Jonas. Would you like me to order a coffee to go?
Mocha no cream?
Utilizing the latest technology in the most relevant manner, Volvo Cars, in partnership with Microsoft, sees a future where voice-controlled personal assistants will make life easier, more productive, and ultimately more enjoyable.
So essentially, computers will become much more human thanks to AI. But I think AI may also make humans more human. What I mean is this: AI will augment our capabilities. It will give each of us superpowers to meet the challenges of all kinds, including some of those biggest ones. Let me share a couple of examples. Starting with education and learning English. To master spoken English, Ideally, each student will need one-on-one tutoring time with a teacher who can provide instant feedback. But the teachers do not scale. Why? Because they can handle a few dozen students at a time with only fragmented attention to each student. AI can help solve this challenge. Microsoft created our own virtual English tutor named Xiaoying. Xiaoying is free to anyone in China via a WeChat public account. Let's roll the video. So even though Xiaoying is only online not for a long time, Xiaoying now has over 80,000 users and practicing and learning to improve English. And Xiaoying is also working with China Daily's bilingual WeChat account, so you can actually test your English skills, from there. So another challenge for humanity is helping people with disabilities so that they can achieve their full potential. So this piqued the interest of our developers in our SwiftKey team, who are best known for their predictive keyboard using neural net and AI technology. So our team used this technology to develop an app to help nonverbal autistic students. Let's take a look at it.
If you're non-verbal, constructing sentences and sort of understanding the semantics of grammar is not really that obvious to you. So the idea of SwiftKey symbols is that you can select a number of pictures from a set of symbols that constructs your sentence. So you can say that an autistic child, for example, could create a sentence using pictures, and the app will read it aloud to their parents or their teacher or their carer, and vice versa.
I feel hungry.
The Riverside school that we're working with has ordered a bunch of tablets so they can roll it out to other classes. It seems to be a successful hit with the kids. They're picking it up relatively easily, and it's helping them use words and concepts that they weren't able to before. And there are a few apps out there that currently do this sort of thing, but we've integrated our predictive technology at SwiftKey to be able to allow users to really quickly navigate through a whole slew of pictures that you would usually take ages going through all the categories by predicting things that you've said before. And that makes it astronomically faster to be able to build your sentence.
So we're very happy that this app is getting great reviews from families with special needs children. The world is full of challenges, but we are optimists. By collaborating with AI, we can make faster and more profound progress in nearly every imaginable field of human endeavor. The future of AI is still an unfolding story. But as the legendary computer pioneer Alan Kay once said, the best way to predict the future is to invent it. As the first generation to live with AI, this is exactly what we will do. All around the world, my dream team, in collaboration with our partners, is working hard to fulfill our mission, to empower every person and every organization on the planet to achieve more, now with AI. We are developing AI that will augment the qualities that make us human. Our curiosity, our caring, our creativity, our emotion, and our universal desire to make the world a better place Thank you very much.